The relation between Cp and Cv. What we have to prove is that Cp minus Cv is equal to R, where R is the gas constant and its value is 8.31 joules per mole per Kelvin. So we will start off by taking the first law of thermodynamics, which is delta Q is equal to du plus P delta V. Now, this is the energy supplied to the system. So, the amount of heat changes with respect to time. So, delta Q upon delta T is equal to du upon delta T plus P delta V upon delta T. Now, at constant pressure, this will be delta Q upon delta T at constant pressure is equal to du upon dt at constant pressure plus P delta V upon delta T constant pressure. Now here we know that the pressure is constant, and we know that the specific heat Cp is equal to delta Q upon delta T. So we will replace this value in this equation, and we will have the equation Cp is equal to, which is the specific heat at constant pressure, is equal to du upon delta T plus P delta V upon delta T. Now let this be the equation 1. Now at constant temperature, we will have delta Q upon delta T at constant temperature is equal to, at constant volume, du upon delta T plus P delta V upon delta T. Now here the volume is constant, so the differentiation of this, the change in volume will be 0 as V is constant. Therefore, this term will be 0. So delta Q by delta T, which is equal to Cv, is equal to du upon delta T plus 0. Now let this be the equation 2. Subtracting equation 2 from 1, we have Cp minus Cv is equal to upon T minus du upon delta T constant volume. Now these terms will be cancelled, and what we will have is Cp minus Cv is equal to P delta V upon delta T. Let this be the equation number 3. Now, for 1 mole of an ideal gas, we can write PV is equal to RT using the ideal gas equation, and also PV upon T is equal to R. Now if the pressure is kept constant, then P delta V upon delta T is equal to R. We will put this value in this equation. We will replace this by R, which will give us Cp minus Cv is equal to R. This is what we wanted to prove. Here, this is the specific heat at constant pressure. This is the specific heat at constant volume, and this is the gas constant, which is equal to 8.31 joules per mole per Kelvin. Thanks for watching.